So this problem asked in the year GATE 2025 under the subject Chemical Reaction Engineering in specific catalyst deactivation. So here we have to match the terminologies in group 1 with the group 2, and the common terminology discussed in this problem is deactivation of the catalyst. So first let us understand the nature of the catalyst surface to address this problem. So let us assume this as a catalyst surface where you have pores. If you zoom any one of the pore, you will have a structure like this. So here the reactants are adsorbed at the catalyst pore, and you have something called active sites inside the pores. So this active sites are responsible for the conversion of your reactant into product. So the key mechanism inside this catalyst surface are adsorption, reaction, finally desorption. So adsorption of the reactant inside the pore, you have active sites that converts your reactant into product. Finally your product will be desorbed from the catalyst surface. So let us get back to the question. So the first terminology is coking. So coking is nothing but deposition of the carbonaceous material on your catalyst surface. So we can clearly understand that because of this coking phenomena, the incoming fresh reactant will be hindered, which means the active sites will be hindered from the fresh reactant. So this will considerably minimize the conversion of your reactant into product. So this coking is very common in petroleum industry process such as FCC, fluidized catalyst cracking. And the second terminology is poisoning. So here what happens, your reactant or even in some cases your product forms a irreversible bond, like through chemisorption process they form a irreversible bond with your active sites. So in that case, so let's say initially these are your active sites. So suppose if your feed has any poisoning molecules or compounds, that first will form a irreversible bond with your active sites. So your number of active sites over the period of time will be considerably decreased. So again this will decrease the activity of the catalyst. For example, in petroleum industry or petrochemical industry, we often notice this unit called desulfurization. So what it does, it removes the sulfur. So predominantly this process is used to safeguard the activity of the catalyst. For example, in Haber process we produce ammonia. So the natural gas will be first treated in the desulfurization unit in order to safeguard your catalyst iron. So the next terminology is sintering. So sintering process is, as we saw initially, so your catalyst metal has lot of pores like this. So when it is exposed to high temperature, this metal oxides try to agglomerate, which means your active sites are considerably getting reduced. So this will affect your activity of your catalyst. So when your catalyst surface exposed to high temperature for a long duration, this metal ions, metal oxides are try to agglomerate, that considerably decreases the active sites. So from the above discussion, we can conclude that coking is deposition of carbonaceous material on catalyst surface. Poisoning is irreversible chemisorption of molecules on active sites of catalyst. Sintering is prolonged exposure of catalyst to high temperature. So P2, Q3 and R1, option B is correct. For more detailed reference, please refer to this NPTEL reference. Thank you.